Hello, Math 107 students, and welcome to the class activities for lesson number 5, where we're modeling with linear equations. So let's take a look at this first problem here. We're going to have two different texting plans, and the first texting plan has a flat monthly fee of $20 and then charges 5 cents per text message. Plan B has a lower monthly fee, flat charge of 5, but they charge 10 cents per text. Both plans include photo and video text. For how many messages will the cost for the two plans be the same? So let's take a look at how we would start a problem like this. Again, you want to be able to read the problem carefully and then describe what it is that you're being asked to find. So in this particular problem, we're being asked to find the number of text messages. So that's where I start off. I just decide what it is I'm trying to find. I'm trying to find the number of, in fact, I could even say monthly text messages, the number of monthly text messages. And we're trying to find this number so that the cost for each plan will be the same. So now we want to assign a variable, any variable we want, X or any other letter, to this unknown quantity. In this case, we only have one. Let's call it M for the number of monthly text messages. All right, now it says write all other unknown quantities in terms of this variable. Well, we don't have any other unknown quantities. What we still need to do is define the cost for each of these companies, but that cost will be defined in terms of this unknown variable. So no others for now, no others, or NA, non-applicable. And so now we have to determine what is equal to what. So we're trying to determine when the cost for plan A will equal the cost for plan B. So when will these two costs be the same? That's the what equals what. So plan A, remember, has an initial flat fee or monthly fee of $20, even if you send 0 text messages. But each text message is 5 cents per message. So that was 0.05 M. I am a little clearer here. So this expression represents the cost for plan B. Now, plan A. Now, plan B had a $5 initial monthly fee, flat fee, but their cost per message, text message sent, is twice as high. It's 10 cents. So we set these two expressions equal to each other. And when we solve for M, we're going to find the number of text messages that you can send that will make the cost for both plans exactly the same. So let's solve this equation here. Let's subtract 5 from both sides. We get 15 plus 0.05 M equals 0.10 M. Okay, so we have our constant term on the left. So let's get our variable term on the right-hand side by subtracting 0.05 M from both sides. So we get 15 equals 0.05 M. And now we want to divide both sides of this equation by 0.05 to get 1 M. So 15 divided by 5 cents, since there's 20 nickels in every dollar, we have 20 times 15, which is 300. Or you probably don't think that way. You'll just throw it in your calculator. Equals M. So that tells us that both plans will cost the same amount when we send 300 text messages. So first, let's check our answer before we write our sentence. So we have 20 plus 0.05 times 300. And we want to see if that equals 5 plus 0.10 times 300. So 20 plus 15, does that equal 5 plus 30? 35 equals 35. Half. So now you can actually see the cost for the plan is $35, because 35 represents this expression on the left side, and this 35 represents that expression. And remember, both of these represented the cost of the plan. So now you can answer with the full sentences. You can say that both plans will cost $35 a month per month when 300 messages are sent. Text messages are sent. Okay, so that's how you start to work on solving these problems. Understanding what they're asking for, identifying all of the unknown parts of your equation with a variable. Sometimes you have more than one thing you have to identify, so you want to make sure all of your unknowns are represented with some type of expression involving a variable. Then you have to say, well, what's going on here? What's equal to what? Because if you can't figure that out, you'll never be able to create an equation. So then you figure out what's equal to what. In this case, when are both costs equal? And then you solve your equation from there. And you always check your work. Let's take a look at another one here. So this next one, you have quite a few problems, or not quite a few, but you probably have like 3 or 4 problems in your book or in your homework. Maybe you have a couple that deals with these sort of discount and markup kinds of questions, where you're either trying to determine the original price of something if it's been discounted, or you're trying to determine the original cost of something if you know the selling price. So they all operate using a similar idea, but how you think about them is very, very similar in both cases, or the strategies you use for how to think about them is similar. So I'm going to try to model some of that for you as I go through these next three or so word application problems. And some of you may say, oh, that takes too long, or I don't want to have to write all this stuff out. But what I'm trying to do for you is to model for you the type of habits that you should create for yourself so that you can become more competent problem solvers. And sometimes that takes time, and there's just no way around that. So let's first read this problem. The selling price of a refrigerator is $584. So I think, having lived in this society, we know that when we go to a store and we see a selling price for a particular item, we know that that item did not cost the store or whoever's selling that particular item exactly the same thing that they're offering the item for you. So in other words, there's always some type of increase that's been added. So this $584 has been marked up. It's been increased by 25% of what the dealer paid for it. So you know that if you go to buy a car, for example, you can always try to negotiate the price that you see on the sticker because there's some wiggle room there. That's not what the car company has, or the people on the lot, the dealer has paid for that car. Okay, so if the markup is 25% of this unknown amount, whatever the dealer paid for it, the question is, what did the dealer pay for this refrigerator? So first, you've got to make sure you understand the problem. And to do that, you need to know the relationship between the dealer's cost and the selling price. So read each of these 2 statements below, and then select the statement that represents the relationship between the 2 prices. So I'm going to give you a minute or so to do that. Okay, so hopefully you chose A, that the selling price of a particular item is always going to be greater than the dealer's cost. All right, let's take a look at this next part of solving story opportunities. And this is the most critical part. You want to identify the quantity or quantities that you're being asked to find and then assign a variable to it. So in this particular case, I should have put a little more room in here because we really have 2 unknown quantities. And maybe I'll go back and edit these class notes so that you have both of them written. The two unknown quantities are what is the amount of the dealer's cost? What is the amount in dollars of the dealer's cost? We don't know what that is. So let's call that D for the dealer's cost, some amount of dollars. The other thing we don't know is the amount in dollars of the markup price, the actual markup. How many dollars was being added to that dealer's cost? And this is the one part of this problem that students often sort of forget about or don't know how to represent. And sometimes I see students just writing D plus 0.25. Remember, percentages have no units attached to them. This D represents a number and it has a unit. The unit is dollars. 25% has no unit. So in order to get the unit in here of dollars, you have to multiply 25% by some amount of money. So the dealer's markup cost, or the markup cost itself, is a piece of D. And what piece is it? It's 25 or a quarter of D. So that represents the markup price. Okay, so this really is one of the biggest keys to solving these equations, is being able to represent what you don't know in terms of a variable. Okay, the next key comes in by seeing if you can identify what is equal to what. So what is the relationship between this selling price and the dealer's cost? You want to be able to make them equal. Right now, you know that they're not equal. The selling price is greater than the dealer's cost. And your job is to be able to put an equal sign between these two things. So you need to be able to recognize that the dealer's cost plus this markup amount, when you add it to the dealer's cost, is what's going to equal the selling price. So now you can put the equal sign into this problem. The dealer's cost was D, the markup cost was 0.25 D, and the selling price is $584. So you can combine these like terms. Remember, D has a 1 in front of it. So 1.25D equals 584. And hopefully that should make sense to you, that if you take the dealer's price and you multiply it by a number bigger than 1, you're going to get the selling price, which is greater. This says that the selling price was all of the dealer's price, 100%, that's the 1, and 25% more. So 125% of the dealer's cost is equal to the selling price. Now, when you divide both sides by 1.25, you get the dealer's cost. So the dealer's cost is $467.20. Okay, so that's found by dividing both sides by 1.25. So let's see what the question asked. What is the dealer's cost of the refrigerator? So you would take that, you would say, in a sentence, the dealer's cost is $467.20. You can always check it by taking 467.20, multiplying it by 1.25, or adding 0.25 of it to get the 584. Okay, so again, you'll have a couple of these to work with in your homework. This next one is a very typical problem. Again, you see lots of these problems. We're going to look at this again in the next lesson. And we're going to use a little different approach in the next lesson. We're going to use 2 variables, but now we're dealing with just 1 variable. So these problems, these stories can have different contexts to them, but the approach, the strategy is the same for every one of them. So we've got this total, and you'll be given some kind of total, whether it's money or total number of pounds or total cups of granola, whatever the story happens to be. And your job, when you get that total, is to represent the two different amounts using just one variable, because you're going to invest this money in two different mutual funds. One invests in stocks, one invests in bonds. So your job is to say, okay, how can I represent two unknown quantities whose total is $5,000? Well, you start by just using a letter like X to represent the amount of, in the units is money, that you invest in mutual fund, the bond mutual funds, bond mutual fund. So I put a little X here. All I know is that whatever I add to X, whatever I put over here, has to equal 5,000. So you say to yourself, well, how do I approach this? How do I write the other amount when I know my total and then the amount I invest in my other fund? Well, one way you can do this is just make this a little game with arithmetic. You can say, well, if I had $5,000 and I put $2,000 into the bond fund, what's left over? 3,000. And how did I get that? 5,000, take away 2,000. But what if I invested 4,000 in the bond fund? What's left over? 5,000 minus 4,000 is 1,000. So to get the remaining amount of money that you have left to invest, you have to subtract the amount of money you put into the bond fund from your total. This will always be true. 5,000 minus X represents the amount of money invested in the stocks. Now, you could have started this problem off by saying X was the amount in the stocks, and then 5,000 minus X is the amount bond. It doesn't matter. Okay, so now you notice if you add these two things together, your X's cancel and you get 5,000, which is what you start out with. So again, this is that first part of the problem where you're identifying your unknown parts, your unknown quantities. And in this case, you've got two. Right now you have two. We're going to end up with two more. Okay. So again, this is the key. Not just immediately go in to try to write some algebraic equation and being, Joe or Jane Macho cool here. You really need to take your time and think about what it is you're being asked to do. All right, so the first part of the problem just deals with the number of dollars invested. That's it. The second part of this problem deals with this concept of interest. It says at the end of a year, the fund investing in bonds has increased by a value of 5%. That means you've earned some interest on that money that you've invested. While the mutual fund that invested in stocks has increased by a little more, 8%. Now, sometimes these can be increases or decreases depending on where you've invested your money. At the end of the year, here's another total coming. Again, we got two totals, but this one is the total amount of interest that's earned from these accounts, and that's $295. So that's where you want to start the remainder of the second part of this problem. You now have this total, $295. This is your interest income. Whereas the 5,000 was the total amount of money invested. Now remember, to get interest, you're taking pieces of each of those original amounts of money. So you need to define those pieces. Well, 5% of the amount of money that was invested in bonds earned some interest. So you notice I'm keeping these at sort of like in the same level here. Here's the amount of money I invested. How much money did I earn in interest on that? It's 0.05 times x. You tell me what x is, I'll tell you the amount of interest. So how do you describe that? Being able to write this next phrase is very important to your understanding of what this algebraic expression means. And the better you get at this, the better you're going to understand how to solve these types of problems. And these next two lines here are the parts that students always want to skip. 0.05x does not represent 5%. See, some students have that percentage in their head, and that's what they think it is. And remember, 5% has no units. You want your amount here, your unknown quantity, to be in dollars. So 0.05x represents the amount in dollars earned on what? The investment of X dollars. That's how much you've earned, interest earned on X dollars. Okay, but this again has two parts, just like this $5,000. This $295 came from two different numbers. We also have some interest that we've earned, some amount of money of interest earned on the remaining amount of money, which is the 5,000 minus X dollars. And that's 8% of 5,000 minus X. So what are some of the issues here for students? Sometimes they represent 5% and 8% incorrectly, like 0.5 and 0.8. That would be 50% and 80%. Sometimes they don't put the actual variable in that represents the amount. Those are some of the initial mistakes that I sometimes see. And sometimes students do not bother writing these four expressions right here. You have four unknown expressions in this problem, four unknown parts to this expression. The two interest amounts and the two amounts of money originally invested. Those are important. All four of them are important for you to be able to solve this problem. All four should be identified for full credit. Okay, so how do we finish this off? Well, if we add these two amounts, we're right back to 5,000. That's not going to help us. There's nothing to solve there. So the only part of this, of these four variable descriptions that we could get a what equals what out is that the amount of interest earned on each of these different funds is going to equal 295. So there's your equation to solve. You just use your distributive property on this second term here, and you get 400 minus 0.08x equals 295. You combine like terms here, you get 400 minus 0.03x equals 295. Subtract 400 from both sides, and you get negative 0.03x equals negative 105. Don't be nervous because of the negative sign here, because when you divide both sides of this equation by a negative amount, you get positive. Yeah? Negative 0.03, divide both sides by negative 0.03, and x is 3,500. So again, we go back to our diagram. We have $5,000 and we've invested 3,500 in the bond fund. So what's left over? 5,000 minus 3,500, which is the $1,500. Now you could also check it by saying it's 5% of 3,500 plus 8% of 1,500 equal to 295. So this is how you can check that your answers are correct. 5% of 3,500 is $175 plus 8% of $1,500 is $120. Those two equal to 90. Okay. So that's how you approach these problems. Again, these four definitions are critical to your understanding of how the algebra is used to solve the problem. Okay, the next two problems are just more problems using one variable, and 4 is a little bit different because you're going to have three different three different unknown amounts with a relationship between them. So this has to do with these salads that you can buy in these fast food chain restaurants, and we want to figure out how many calories are going to be in each one of these salads. So there's a relationship given to you, and if you remember what I talked about earlier, which one of these salads do you designate with your variable? X, S, M, I don't care what you call it. How do you determine that? Again, try to determine which one of these salads has the smaller number of calories, because everything else is being described in terms of that salad. So Taco Bell Express taco salad is 125 calories more than Burger King's chicken Caesar salad. All right, so there's a beginning. The Taco Bell, the number of calories in the Taco Bell salad is more than the Burger King number of calories in the Burger King. So right now we know that the Burger King is the smaller amount of calories. Okay, we've got another one going on here. Wendy's Mandarin chicken salad is 95 calories more than Burger King. So it looks like Burger King's going to be the winner in terms of the smallest number of calories, because Wendy's salad, the number of calories in that is also more than the Burger King. So this is how I determine the variable, the initial variable for my problem. What will I let X or C here for number of calories equal? So I'm going to let C equal the number of calories in a Burger King salad. I'm not going to write all what kind of salad it is. That's irrelevant. Now my job is to write out, in terms of C, the number of calories that's in the Wendy's salad, the number of calories that's in the Taco Bell salad. And they're both greater than the Burger King. Well, the Taco Bell salad is 125 more calories, so X plus 125 represents the number of calories in the Taco Bell salad. And the Wendy's salad is 95 more calories. Oops, look, I used C and then I used X. See, I'm so used to using X. I wasn't paying attention. We don't get very far if we have two variables here. So let's go back and put C. All right. What equals what? All three of these salads. The number of calories in 3 salads is equal to what? They've got to give me a total amount. Oh, thank goodness, here it is. 1,705 calories. So I set up my equation. C plus 95 plus C plus 125 equals 1,705. I come up here, 3C plus what? Let's see, 220 equals 1,705. 3C equals, I subtract 220 from both sides, 1,485. And now I divide both sides by 3, and I get 3 goes into 14, 495. Okay, so now I can go back and fill in everything I need to know here by going back and replacing C with 495, the number 495, and then 495 plus 95 is going to be what? 590. And then 495 plus 125, 620, I believe that's right. I did the mental math correct. Let's see, I'm going to add it up and see if I get 1705. So 500, 5, 9 and 9 is 18, and 2 is 20, 6 and 6 is 12, 1705. Once again, a happy camper. Okay, we've got one more to do, and then we are done with this class activity. This next one involves area, perimeter type of problem. In this case, it's just perimeter. And so it's a geometric. And I never do these problems without ever drawing. I always draw a diagram, always. So I've got a football field. This is a true thing here. I looked this information up. And notice it's an American football field, which is different than world football, which is what we call soccer. All right. Oh, you got my Boston accent. Okay, so the length of a football field is 200 feet more than the width. Are you getting used to this idea? What's the smaller number here? The measurement of the width, right? The number of feet in the width. So that's where I'm going to start. I'm going to let W equal the number of feet in the width of the football field. The length, the number of feet in the length is more than that. How much? 200 feet more. So there's my second unknown quantity. And now I can just do ditto, 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 oops, length of football field. Okay. So W plus 200 is my length, and W is my width. Now here's a little strategy you can employ to help make this equation just a little easier to solve. Students often read the next sentence here and say, okay, the perimeter of the field is 1,040 feet. And they immediately go to perimeter is 2 lengths and 2 widths. Okay, great. You remember your perimeter. Your perimeter is the distance around your rectangle. It's a linear measurement. But do we really need 2 lengths and 2 widths? So why not just add 1 length and 1 width, and that will give us half the perimeter. You can do it either way. So the perimeter is 1,040. If I take half of that, I get 520. And now I can add 1 length and 1 width. So 1 length is W plus 200, and 1 width is W. So I get 520 equals 2W plus 200. I subtract 200 from both sides, and I get 320 equals 2W. So W equals 160. So the width is 160 feet if I put my units on it, and the length is 360 feet. So that is how you would approach this problem. Okay, I just want to show you that it really doesn't matter if you went ahead and do it with the original formula you probably put down. It's just a little more work. You have to use a distributive property. Anytime you have more work to do, it leads you to potentially maybe making a mistake if you have more steps. But again, you can see that I get exactly the same answer. I do this right. 400 minus this. I was working so fast. Pull out my calculator. It made a little mistake. Here I am trying to convince you it doesn't matter, and then I make a mistake. Where's the calculator? Hang on. Okay, I didn't make a mistake. If I divide both sides by 4, I get 160. I guess in my head when I divided by 4, I was getting 180, which was not correct. So my calculator verified that the 2 answers are the same regardless. But as you can see, why have the full perimeter when only half the perimeter is needed to solve this equation? Okay, well that's it for this lesson, and let me know if you have any questions.